Hello students, welcome to the second lecture on states of matter. In this lecture we are going to discuss the behavior of the most simplest states of the matter, that is the gaseous state. We are living in the ocean of air. You can see everywhere there is a air. We cannot see it, but it is there. And the air is basically the mixture of different gases. In this lecture, we are going to discuss the behavior of those substances which exist at the normal temperature and the pressure in the gaseous state. And it is basically found that total there is 11 elements in the periodic table that exist in the gaseous state. What are those 11 elements? That is hydrogen, then nitrogen, oxygen, chlorine, fluorine, and all the noble gases. That is helium, neon, argon, xenon, krypton, and radon. All exist in the gaseous state. So today's lecture is regarding the gaseous state and its different laws. Gaseous state is the most simplest state because the intermolecular force of attraction is negligible and the gas having the very unique properties if we compare with the solid and liquid. It is highly compressible, that in case of solid and liquid you cannot find it feature. Second, it exact pressure in every directions. Third, it has very less density. Fourth, that it do not have any shape or volume. It will assume the volume of shape of the container where it has been kept. And the most important that it can easily mix with itself to equal proportions. That is again a very important characteristics. So in this lecture we are going to discuss the gaseous law. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. What is gaseous law? Let us understand. Gaseous law is nothing but the interrelationship of the measurable parameters. What are those measurable parameters? There are basically four measurable parameters that you can see. That is one, that is the mass of the gas. One, the mass of the gas. Second, the volume of the gas. These are all measurable parameters. Third, the pressure of the gas. Pressure of the gas. And last, the temperature. Mass of the gas is basically denoted by N, number of moles. Volume is V, pressure is P and T. There is a four very important measurable parameters, and the interrelationship with these four parameters will going to give us the gaseous law. Over a period of time, different scientists have tried their best to find out the interrelationship between these measurable parameters, and this interrelationship of these measurable parameters will going to give us the state of the gas. So in this lecture we are going to discuss the very important gaseous law. First we will discuss the Boyles law. Boyles law is basically tell about the pressure volume relationship when we keep T and N is constant. T and N means temperature and number of moles, that is at a fixed amount of the material. So what Boyles say, after making a lot of experiments, Boyle gives his law like this. It states that at constant pressure, at constant temperature, and for the fixed volume, for a fixed mole of gas, volume V changes inversely, with pressure. So volume changes inversely with pressure. So mathematically we can write the Boyle's law with this way. And we are taking this equation with this. K1 is a proportionality constant and it is given by this. This is a very, very important equations of the Boyle's law. Now, what is K1? K1 is the proportionality constant. K1 is proportionality constant and it depends on the temperature of the gas. Number 2, the amount of the substance, amount of the gas means N, amount, that is N. And also it will depend on the units of the volumes and the units of the pressures. So this is the equation of the Boyle's law, and this can be represented graphically. How we can represent it? Let us see. This is the volume we are keeping in the y direction, y axis, and pressure in the x direction. Then we will observe there is a very important thing. This type of curve will be there. And suppose this is T1, T2 and T3. They are basically the fixed temperature. In this temperature we have experimented and we have found the pressure volume relation is this. Means when pressure increases, the volume will be decreases and vice versa. So when the pressure has been reduced, then volume will be decreases. So this is the relationship, and this relationship has been reflected here at the different temperatures. You can see here T1 is greater than T2, T2 is greater than T3. At a higher temperature, the higher curve is basically correspond to the higher temperature. So this is the graphical representation of this, and you can find the K value for this each curve is different because of the fact for the fixed amount of the material, fixed mole of the gas, the constant will be different. That is why you see, and this curve, this different curve is called the isotherm. This different curve is called the isotherm. And this graph, we can physically represent it in another ways also, that we are going to discuss. This graph can be represented in this way also. We are taking inverse of the volume in the y-axis and pressure in the x. At that time also, what we find, at the different constant temperature, these graphs will be like this, where it is T1, T2, T3, and it is T1 is greater than T2, T2 is greater than T3. And in this case, what we also there is a straight line, and the straight line goes through the origin, and this is the graph when we plot 1 by V versus P. And it observe when the pressure is very high. When the pressure is very high at that time, this graph will not be the straight line. And that means at the highest pressure, gas will not follow the Boyles law. And this will be discussed when we discuss about the real gases. At that time, we will discuss how it is so. So this is another representation, and we can represent in the other way also. When we plot P versus PV for the constant temperature, at constant temperature, we can write at constant temperature for fixed amount, for fixed mole of gas, what is there? Now PV, product of the pressure and the volume, will be always a constant term. That you can see this graph is parallel to the x-axis. So PV is constant, and that we can understand from this Boyles law, that is K1 by P is equal to PV is equal to K1. So this is basically the graphical, this is the mathematical expression, and this has been plotted in graphically. So what we understand from the Boyles law, we understand one thing, that gas is highly compressible. When the gas has been compressed, suppose this is a gas, initial volume suppose is V1, and it will compress it here with the V2, that is we have reduced the temperature, reduced this in the volume, and at that time suppose there is a P1 and it is a P2, then we can write from the Boyles law, that is a very important, P1 V1 is equal to P2 V2, and this relation we can utilize dividing numericals. Suppose one, how much pressure to be increased, when volume is decreased by 5% at constant temperature and fixed amount of gas. For this, what we will do? We will just use, there is the option is giving 5.26, 4.3, 6.2, none of the above. For that, what we will do? We have to use this Boyles law. Here P1 is not given, only given that volume has been decreased by 5%. Means if the volume V1 is 100, then V2 is equal to 95. Right? So you can put 100, P2 is equal to 95, then is equal to V2, then This is a P2. Now we P2 by P1, that will be given by 100 by 95. So just what we'll do, we just put a minus for both the points. So it will be giving P2 minus P1 by P2, and this will be give 5 by 95, and if we express this in the percentage, what we will get? We will get it is 5.26%. So for the 5% decrease of the volume, we have to increase the pressure by 5.26%. Okay. Now, as the gas is compressed with a fixed volume, what we find? Now there is a decrease in the volume. So if the volume is decreased, then the density of the gas is going to be increased, and that you can prove from the Boyles law also. We know density is basically D is equal to M by V. M is the mass and V is equal to volume. So by the Boyles law, you know V is equal to K1 by P, and when we put this, it will be coming around M by K1 by P. At that time, it will be, this is the pressure and this is the density. So what we get? M into P by K1. And here, as per Boyles law's condition, the M and K, these are constant. So we can say density, this is the density. Density is directly proportional to the pressure for the fixed amount. This is a very important relation. Sometimes questions may ask from these relations also. So that is for the Boyles law. Now we are going to understand another very important law, that is the Charles law. Charles law is basically the correlation between the volume and temperature at N and P constant. While experimenting, Charles found when he increased the volume of the gas, when the temperature is increased, then volume of the gas also increases. And when he cool down the temperature, when the temperature is reduced, then volume of the gas is also reduced. He also found out that this increase and decrease of the volume with the temperature can be quantitatively also be defined. How? Now 1 degree Celsius increase or decrease of the volume, 1 degree Celsius decrease of the temperature will increase or decrease the volume by 1 by 273.15 of the volume of the original volume, that is at the 0 degree Celsius. So what we observe, the increase in the volume, what Charles law says, the increase of volume by the increase of temperature, increase or decrease of temperature, both are applicable. Increase of temperature by increase of temperature by 1 degree Celsius or we can say decrease also there. Decrease of temperature by 1 degree Celsius, the volume shall increase or decrease. Volume shall increase or decrease by 1/273.15 of the original volume at 0 degree Celsius. Suppose the volume at 0 degree Celsius and T degree Celsius is given by V0 and Vt. So we can write Vt is equal to V0 plus V0 by 273.15 into T. So we can write this Vt is equal to V0 by 1 plus 1 by 273.15 into T. So this is when the volume has been increased, that we can able to find out by volume, the temperature has been increased, we can able to find out the increase in the volume from these relations. Okay. Next, a point where there is a generation of the new temperature scale. New temperature scale is T degree Celsius. In new temperature scale is, suppose this is capital T and it will be 273.15 plus T. T degree is in the new temperature scale, you have to add this 273.15, and 0 degree in the new temperature scale, that is represented by T0, it will be 273.15. This temperature scale is called the Kelvin temperature scale or absolute temperature scale, or it is sometimes called the thermodynamics temperature scale. This is a new temperature scale. Now we put this value in this equation. So what we get? We get Vt is equal to V0 by 273.15 plus T by 273.15. Now you see V0 273.15 plus T is equal to capital T. This is capital T. Now it is that 273.15 T0, put this T0. So we get this relationship, that is Vt by V0 is equal to T by T0. Now we can write this way, Vt by T is equal to V0 by T0, or we can say V by T is equal to constant. This is called the Charles equations, Charles law equations. This is a mathematical expression of the Charles law. V by T is equal to constant, and here you can write V by T is equal to K2. And here T is the temperature in absolute scale. That is a new temperature scale has been arrived, that is given by this. Then we have to suppose 25 degrees Celsius in the Celsius scale. Then in the new temperature scale, it will be 298 Kelvin. But in this case, we will not apply the degree. We will only write K. Okay. So this is the Charles law. It says what it says? It says Charles said at constant pressure, for a fixed amount of gas, fixed amount of gas means N is fixed, then volume is directly proportional. Volume is directly proportional So mathematically we express V is equal to, mathematically we express that is V is proportional to T, or it is V is K2 into T. That is the mathematical expression of the Charles law. And by language we can say at constant pressure, this you have to write at constant pressure for a fixed amount of gas, the volume is directly proportional to absolute temperature. Not simple temperature, it will be absolute temperature. Now we will try to understand the graphical representation of this Charles law. When we graphically represent it, what we find? We take the temperature in the axis and this. Temperature in the Celsius pressure. At that time, what we will find? For majority of the gases, it will have a straight line. It will have the straight line. So you can see this will be volume. This will be a straight line, but at the different constant pressure, every gas will meet at the zero volume axis. Zero volume axis means in the temperature axis. This is a 0 degree Celsius, the temperature axis, and this curve is like this. So what we find, the curve is straight line. This is a straight line curve, P1, P2, P3. Here P1 is greater than P2, P2 is greater than P3. What we find, that curve is a straight line and have the different slope, but when we extend this curve, it will meet at the minus 273.15 degrees Celsius. This means at that this is a zero volume. At that point, the gas will achieve the zero volume stage. Means gas is no longer the gas; it becomes liquefied. And practically, it is observed below this, above this temperature, all the gas become liquid. But this is called the absolute temperature because at that point the gas state is no longer exist, gas become liquid. And if we put this temperature, V is equal to V0 273 T by 273. And now if we put this T is equal to minus 273 Celsius, so what is going to happen? The V is becoming 0. So this temperature is called the absolute temperature in which the gas no longer exists as a gas, it will become liquid. So we understand this is the main points, and this graph is, there's a constant special graph, this is called the isobar. As we understand, in case of Boyles law, isotherm graphs, and it is also called the isobar graph because it is in a constant pressure. So now discuss some numerical. These are the 4 graphs we have plotted, and you have to say which is the correct representation of the pressure versus temperature graph. And this is the temperature, this is all temperature, this is all temperature and temperature, and here it is giving the volume. Which is the correct graph? 273 Kelvin, it will be at that time the volume is your, this is the volume. This is volume to 22.4 liter, and it will, when it is increased the temperature 373 Kelvin, it will become 30.6. Here in this graph 224 to 41.2 liter. Here in this graph 224 to 28.6, and here you can see the now which is the correct graph. So for that we have to recall that V by T is equal to V1 by T1 is equal to V2 by T2. So in this case, what we will do, the initial temperature and volume is given here. So what is this initial? 22.4 divided by 273 Kelvin is equal to V2 T2. T2 is given 373 Kelvin. So you have to calculate the V2, and you will find the V2 will be 30.6 liter. Means this A is the correct answer. In this way, different types of graphs will be given, and you have to say what will be the correct choice. So that is all for today's lecture. Today's lecture we have discussed about the 2 very important gaseous law, that is the Boyles law and Charles law. And another thing that we need to understand, the Charles law will, in the lower temperature, the gas follow the Charles law. In the lower pressure, the gas follow the Charles law, or that is because of the real gas and all the things. So we will discuss in detail when we are talking about the real gas, what is the real gas and how they are deviate and what is the reason behind this, that we will discuss later on. And that is all for today's lecture. If you like this lecture, you can share it to your friends. Thank you very much for watching.